Hello. It is April 12th, about 2:30 p.m. The challenge here will be a random roll for a lens mirror problem. First, I must determine if I have a lens or a mirror. So, what do I pick? Odds, lenses, evens, mirrors. Odds, lenses, evens, mirrors. All right, so I have a mirror. Concave, odd, convex, even. Convex, even. Concave, odd. So I have a concave mirror. That obviously means that the focal length is greater than 0. It is a converging mirror. And that the focal length is going to be on the left, and f prime will be on the right. So now I need a focal length for this lens. What we're going to do to make things okay with it, roll 20-sider plus 10. 20-sider plus 10 to determine the number of centimeters in the focal length. So the focal length will be 25. I'm trying to avoid very low numbers, so that's why I add 10 to it. So 25 centimeters. And it's a converging mirror, so it is positive 25. Now I need to have, now I need to do an optical position. Once again, 10 plus the d20. So optics, or the object, will be at 17 centimeters positive. Now, with these two, immediately we just do numbers. We don't draw anything. No pictures. So I is equal to 1 over f minus 1 over o. I know that's an object, not a 0, so I'm content with drawing it that way. That makes it 1 over 25 minus 1 over 17 inverted. So this becomes minus 53.125, 53 and an eighth. Now all of these units are in centimeters. As long as the units are the same, it's okay. I also need magnification. Magnification is negative I over O. So this is negative I, or negative of a negative 53.125, and O, which is 17. So I get a positive 3.125, 3 and an eighth, as the magnification. That value, the image, is less than 0. So we're dealing with a virtual image. Virtual images on a mirror are to the right. So this is 53.125 centimeters to the right. The magnification is greater than 0, so the image is upright. The magnification magnitude is greater than 1, so it has been enlarged. So our key values, the key is the key. Virtual to the right, upright, enlarged, image distance of there, and that's a lot of the information that we need. Now we can start drawing. This will be to scale. So the first thing I need to do, this image is going to be 53 to the right, object focal length 25 to the left. So if we do 25 there, And then we do 1, 2, 3, 4, 5, 6, 7. All right, we got the space. So first step, in black, optical axis. Then what I'm going to do is I'm going to pick each of these block to block as 10. So 53 and 1/8 will be that. So if the image, you typically start with the image or object, the optical object, which is the biggest number. So that's 53 and 1/8. Oh wait, 53 and 1/8, 50. So that would be 55. All right, so we gotta back this up just a bit. That's 55, so that's about 53 and change. So that will be the 3, 10, 20, 30, 40, 50. Probably I could choose a better scale, but I really love this this ruler. All right, this is the lens, or in this case, the mirror wall. It is, we don't use the optical instruments because it just, I don't get accurate behavior from the rays if I try to do the mirror or the lens and I try to draw through it and show the, and in the case of the lenses, the refraction. So it's best just to draw a line and draw it accordingly. So that's I. The focal length is 25. So focal length is there. For concave mirrors, the focal length is to the left. For reference, we do f prime, which is the same distance but on the other side. The object is 17, so this will be 10, 15, 17 is about there. So now I've positioned everything. The image is 3 1/8 times large as the source. So if I do 3 1/8 for one block, it is roughly this. And it's positive, so it's upright. And then the object is this. So there we go. Object, focal point. I call this antifocal point, image point. And now, let me get the Sharpies. Green, silver, no, gold, no, red, yes. Let's see what else we got. Blue. All right, the 3 rays, I do them in a very specific order. First ray, blue ray, or the colors can be random, I don't particularly care, but the order I tend to do in a very specific way. For a mirror, you always start at the tip of the object. I'm going to lift it up because the nub of the pin is a little bit on the fat side. And so what happens is the ray reflects and you trace that back. And that's the first ray. And if we were doing this very precisely, that angle and that angle would be the same. Law of reflection. Second ray. Now with this, it starts parallel. So the ray goes like this. Okay. Now with this particular ray, it converges at the focal point. So the ray is going to do this. But what also happens is if you trace the image back, you get that. Now the third ray. Third ray is a sneaky ray. Third ray, it depends on the orientation of the whole thing, but the one thing that we do know for the way that I draw this is that the third ray is a virtual ray, and that third ray becomes parallel. So we get this. And how I typically do it now, as I've been doing this quite a few times, is I draw the parallel line coming from the image. Since this is a mirror, it is a virtual line, a dotted line to the right. Now, how you get that is the ray that becomes parallel is a ray that if it went backwards, it would be at its focal point. So it's focal point, object point, mirror wall, and then becomes parallel, and then you do a trace back. And so this is, the technique is always the same. You get your I, you get your M, you identify the qualities of the image, magnification, position, everything, and then you start tracing rays. First ray, always through the middle of the ray, or through the mirror. In this particular case, it reflects perfectly, and you trace back. Second ray starts parallel, shot away from the focal point or aimed at the focal point, you trace back. In this last ray, it becomes parallel, and in this particular case, to set that up, you go from focal point to object to the mirror wall, and that's it. So concave mirror, we just randomly threw out numbers, and that's how we do it. I'll do more later. Thank you.